Welcome to the sixth part of Building Robots System Integration. My name is Gaspar Škol from University of Ljubljana, and today we'll continue learning about the wireless control of a mobile robot with a focus on user interface. We'll discuss different implementation possibilities and their influence on robot control. At the end, we will also look at this week's project assignment. A human-machine interface is a communication system between the user and the used device. The interface gives the user ability to get information from the system and also input information into the system. When designing a robot, it is important not only to create connections between its parts, but also its users. When thinking about a human-machine interface, we would usually think of a touchscreen, a control panel, or a software application. These are all very capable solutions, presenting a lot of information and allowing for many different actions from the user. However, human-machine interface doesn't need to be very elaborate for it to be effective. Even a single LED indicator can be very useful in conveying information. If we remember the green emerald board, it has several LEDs with different colors. When the battery is inserted, it can be inserted the wrong way. Because the board is equipped with a reverse voltage protection circuit, no damage will be done. But without the red LED lighting up, the user wouldn't know what is wrong. The user might even assume the battery is empty or the board has been damaged. And the red color was used because we associate it with errors. Green, on the other hand, is usually associated with recognition that something is correct. When the board is provided with 3.3 volts, the green LED next to the voltage regulator is lit, reassuring the user the system is properly powered. This kind of low-level information is best provided in a simple way directly on the hardware. When designing a robot, we should always include indicators that allow us to easily identify if something went wrong and narrow the possibilities as much as possible. However, with too many indicators, we are wasting space on the PCB and resources that could be used more effectively elsewhere. For information input, tactile buttons and switches are an effective way how to simply input a change of state. In the case of the power supply board Emerald, a combination of a switch and a button is used to power up or shut down the battery supply. This is a robust solution that doesn't consume any power when the robot is shut down, and it is almost impossible to accidentally power up the robot. Systems that could be dangerous must be additionally equipped with a big red emergency stop button that will directly cut the power supply. When we want to convey more information, like in a form of a number, text, or an image, a more capable interface device should be used. And now we come back to devices with a touch display, like a ubiquitous smartphone or a tablet if we need a bigger screen. Use of a touchscreen is useful because we have a lot of flexibility in the interface design, can easily modify it, and use the same device for multiple interfaces. Instead of using a keyboard and a mouse, users can interact with the interface with their fingers. In our case, where we want to control the motion of our mobile robot, we will on the smartphone screen display two joysticks. The user will place finger of one hand on one joystick and finger of the other hand on the other joystick. Joystick positions will be controlled by movement of the fingers. If positions change, information about reference speed for each wheel will be sent to the robot. moving the joystick up from the middle position means a positive speed reference, and moving it back a negative reference. Speed reference is linearly proportional to the joystick's offset from the middle. If finger is no longer in contact with the joystick, it will jump to the neutral middle position and reference speed will be updated to 0. While it is possible to design such interface from scratch, we will use an already developed and tested library. When we decided to use a smartphone for our interface device, there was still an option between web or native application. A native application is specifically built for a particular smartphone operating system, iOS or Android. The developed application must be installed on the phone either directly or from an app store. The application can therefore start without internet access. Because the application directly uses the device hardware, it can have better performance than web applications and also has full access to the system sensors. Web applications, on the other hand, run in a web browser and are not installed on the smartphone, but loaded from a server. Because of their dependency on a browser, they run slower and have limited access to the system sensors. For our control interface, we selected web application because it has to run on any smartphone and shouldn't have to be installed. This allows for a quick setup when a new person wants to control the robot. Hosting of the web page is solved by using the communication module on the mobile robot as the web server. Our application also doesn't require much resources, so it can be stored within the microcontroller's memory and run on a browser. At this point, we can also mention the difference between cloud and edge applications. A cloud application runs and stores data on a remote server and is far from where data is being gathered and decisions implemented, while an edge application is close to the observed or controlled process. An edge application, in comparison to cloud application, can respond faster, is less dependent on communication, but is, because of limited resources, less flexible and harder to scale. When controlling a mobile robot, we want our applications to be close to the edge because any additional exchange of data between devices increases response time. Use of a cloud applications becomes useful, for example, for global path planning when a lot of computational resources are needed and longer delays are not critical. Your task for this week is to create a web page and a microcontroller program that demonstrate a simple user interface. First, create a web page that establishes WebSocket connection with a WebSocket server on a microcontroller. The website has 3 buttons: forward, break, and backward. If the forward button is pressed, number 1 is sent to the microcontroller. When break button is pressed, 0 is sent, and -1 is sent when backward button is pressed. Microcontroller handles the message and prints via USB serial connection to the Arduino IDE forward if the number is 1, backward if the number is -1, and break if the number is 0. The website is hosted by the microcontroller that also acts as an access point on which you connect with the smartphone. Human-machine interfaces on the mobile robot can have many different levels of complexity, from simple indicators to virtual controllers and 3D visualizations. There are also many different technologies to pick from when implementing a user interface, and their selection is not an easy task. Thank you for watching.